Bienvenidos, Ushamdi, and welcome. CMIT 454, sections 6380 and 6382 for the first 8-week term of the spring 2018 semester at the University of Maryland University College. This is the Cisco Networking Academy CCNA Security version 2.0 course, and this morning's Packet Tracer tutorial and solution set is going to be on Packet Tracer activity 9.3.1.1, and this is the penultimate Packet Tracer activity for the course. After this, we have the culmination of our course Packet Tracer activities with the skills-based assessment. And so in this Packet Tracer activity, we're going to be taking a look at how to configure a Cisco ASA firewall. And we're going to be looking at some of the basic settings for the Cisco ASA. Now, I would also like to let you know that I will be posting the links to this video series that I did over the summer, sort of toward the beginning of the fall or the end of the summer here. And initially this was going to be something I put up on Udemy, and I just decided to go ahead and put it up here for access. And it starts out and it goes through in great detail, literally from start to finish, receiving an ASA 5505 firewall, whether that's a hand-me-down that you got or something you picked up off eBay. I go over all of the steps to literally take it from password recovery when it shows up on your doorstep to doing the file system cleanup, the OS management, basic settings, remote access, network address translation. We actually go over the modular policy framework in 2 videos in great detail. We cover the same security traffic interface, like when traffic is going between interfaces in the same security level. I go over the DHCP. I actually show you how to set up the clientless SSL VPN, the AnyConnect SSL VPN. We do split tunneling, and I actually demonstrate all of this with showing you how to connect with not only a laptop to get into your network from home, maybe if you're on the road, but also how to connect with an iPhone. And I actually display the iPhone screen while I'm doing these videos so that you can see everything that's being done. And so I'll be posting the links to these. These go much deeper into the ASA configuration. And again, it's really a video series that was done to say, hey, if you want to get a 5505 off of eBay, or if you get a 5505 somehow, Craigslist, whatever the case may be, here is everything you would need to do to literally go from start to finish to plug this into your network at your house and to get everything set up. Okay, so let's go ahead and jump into our topology here. Now, this is the first time we've seen a firewall introduced into the topology. We've, as a device, we've used the zone-based policy firewall, the context-based access controls, and now we have an outside interface here, which I will do as red. We have an inside interface, sort of our trusted interface, and then I'll do blue for what is going to be the DMZ interface. Now, the ASA 5505 or the 5500 series firewalls are great firewalls, but it's worth noting that these are now legacy. So 55, I believe it's 06X at the low end, that is sort of the newer ASA low-end firewalls, the 5506. Now, the 5505 is a little different than the other firewalls that you'll see in the ASA lineup. And the reason for that is there are 8 interfaces on the back. In fact, if I click on the firewall here and you take a look, it actually looks just like this. So we've got 8 interfaces on the back. And it's different in the sense that, and I'm going to make a routing and switching analogy here. It's different in the sense that when we're configuring the interfaces, we're not actually putting the IP addresses on the physical interfaces of a 5505. And again, this is different than all other 5500 series firewalls. The 5505 is a special case where it's really more like a switch virtual interface configuration. And what do I mean by that? Well, what we're going to be doing is we're going to be configuring SVIs. In other words, VLANs that we're going to give names to. And the names are going to be representative of the firewall interfaces. So inside, outside, DMZ. And that's how we're going to name our quote unquote switch virtual interfaces, or our VLAN interfaces. Then we're going to put an IP address on there. Then we're going to go ahead and we're going to give it a security level. And this is going to be a number from 0 to 100. And I also have I've got a couple 5505s here at my house in my rack. And so we're going to be doing the tasks in tandem so we can see what it really looks like. Because this is Packet Tracer. And again, Packet Tracer is an amazing tool. However, I want to make sure that you get a true sense of what you're going to be seeing and how the commands are going to behave. And so I've got a real firewall, and we'll work these things in tandem. So I've got the ASA up here. Let me go ahead and bring it down over here, and let's stretch this out a little bit to give ourselves a little bit more room with which to work. And we'll get the CLI interface up. And so we've got, what do we have here? We have our DMZ server. We've got PCB, which is on the inside, VLAN 1, and we have PCC. So let's bring the firewall back up. All right, so we've got our objectives, a lot of stuff going on here, and then the scenario. So our company has one location connected to an ISP, and so this is the ISP router. That is the outside interface, right? And you can see it's indicated as being outside, and we're going to be using VLAN 2 for this connection. Excuse me. And so that's our outside connection. And in other words, think of it as like this is Verizon out here. Right? So router 1 is the Verizon connection that we make when they hand off the coax, or not the coax cable, they hand off the Ethernet cable, Cat 5, Cat 6, whatever the case may be, and we're going to plug that into our ASA 5505. We have a range of addresses here, so we're going to have a static, right, inside this subnet. We're going to be working with a static. In the video series I show you how to set it up with DHCP, so that if you don't have a static IP, you can do DHCP just as easily. Now, let's see what else we have here. So it's interesting. It says this packet tracer activity is not a substitute for the ASA labs, right? And again, yeah, it says there may be some differences in the command output and the commands that aren't supported here in Packet Tracer, and this is extremely true in this activity. And that's why I have a real 5505 up. So let's dive in here and let's get going. So verify connectivity and explore the ASA. You'll notice that the completion percentage is already at 20%. And the reason for this is that things have already been done for us. If I was to click check results, we can actually see what has been done right now. And it's, again, it's a software simulation, so they've already sort of pre-canned or given us points for the DHCPD, the auto config, the DHCPD enable, even though we're going to be running these commands. The same thing here, the VLAN 1 name interface. And you'll see that it behaves differently than a real Cisco A when we enter in the interface name. In other words, you're going to see that we, on a real ASA, we're going to get a message that gives us the, like when we do the outside or the inside, when we say name if inside, name if outside, the ASA, a real ASA, is smart enough to say, well, it's obvious that your outside interface, we're going to put that at the highest security level. And I'll talk about traffic going from lower level security settings, and lower being a lower number, to higher zones, and then from higher zones to lower zones, and how that works by default. And then you can see the VLAN names have already been sort of, we've gotten points for that, and it has a lot to do with the fact we've already gotten points for name, if, and security level. So we do have some points, so don't think that that is a bug. And I did not want it to shrink the size of that, so let's do this here. And there we go. And then let's drag this back over to here. And we'll give ourselves a little more room with which to work. Again, I want to make sure I lay the groundwork here because there is typically a little confusion on this activity just because it doesn't behave as it's supposed to, like a real ASA. So We're going to verify connectivity. The ASA is not currently configured. However, all of the routers, the PCs, the DMZ server are all set up. So we're going to verify that PCC can ping any router interface. PCC is unable to ping the ASA, PCB, and the DMZ server. So here's PCC, and let's make sure we can ping the router interfaces. So can it ping router 3 and router 2? And so let's just go ahead and hop onto the desktop here, get into the command prompt, and we're going to say ping 10.2.2.2. And I'm not sure if the 2 is that address or this address, but it is in the /30, so we know we can hit that. Can I hit the 1? And I can. Now let's test the other 2 usable IPs, and that's /30. And I'm going to say ping 10.1.1.1, and we can do that. And let's ping 10.1.1.2. So from PCC's perspective, we've got connectivity all the way over here to router 1. Now, remember, it's unable to ping the ASA or PCB or the server in the DMZ. And that is because the ASA is not configured at all. And now it may be that as we work through this, we find out that it's just that that's a limitation of the activity. Okay, step 2, determine the ASA version, interfaces, and license. And so we're going to use the show version command to see that information. So here we are. And again, you can think of it as user exec. We're going to transition to privilege exec. Now, this typically throws learners off, as we were shown a whole bunch of passwords, but watch what happens when I hit enter. Yeah, so there is, by default, no privilege exec password. No enable password is set. So all you do is hit enter, and it's going to let you into privilege exec mode. Now, if we transition over to a real Cisco ASA, you can see here that it's just booted. And so I'm going to say, no, we don't want to go through the interactive prompt. So here I am at that same Cisco ASA user exec mode prompt. So if I say enable to transition into privilege exec, I'm prompted with the password command. But when I hit enter, it does exactly what we see in Packet Tracer. So I say show version, and here we go. It shows me that I'm running 847.31. And again, this is very old code here. The 9.x branch of code is where you should be in a production environment. But for a lab environment, this is just fine. And as you saw above here, you'll notice that it says minimum memory requirements not met. So I'm getting this warning message here. And I actually have a 512 meg DIMM that I ordered off eBay. It's been sitting on my rack, on the top of the rack for probably 9-10 months, because I only have 256 meg. And the video series I did goes into all of the details required to figure out, how much RAM you need, what version you should be running in order to not get this message. And you can see the upgrade part number, and this is nice, right? And that little equal sign means it's sort of what's the word I'm looking for? You're ordering just this part, not part of a bigger configuration. Spare, that's the word I'm looking for. It's a spare. So the ASA 5505 MEM. So you can find these on eBay. I think I got mine for $5.99, right? If you wanted to get an ASA 5505, upgrade it to 512 megs of RAM. And if you look at the later releases, I think version 7 or something like that, they came with 512 meg of RAM. And I've ordered one that came with 512. I ordered one with 256 because I was going to leave it here. And you can see it says you got to downgrade to 8.2, which you do not want to do because there are some significant syntax differences between the 8.3 and below code and the 8.4 and above code. All right, so we can see that we're booting to this image here. And now we take a look at the interfaces, right? So these are the physical interfaces that you see listed, right? Ethernet 00, 1, 2, 3, 4, 5, 6, and 7. So those are my 8 physical interfaces. And as we make our way down here, you can see that we've got licensed features for this platform. So for VLANs, I have 3, and you notice it says DMZ restricted, and we're going to see this in our activity when we go to do the DMZ configuration. I think we're going to say no forward VLAN 1, and I'll talk about that when we hit it. Dual ISPs is disabled, and so again, you can see that these are the features that I'm able to use. AnyConnect Premium Peers, right? I get 2 by default, that's okay. And we're limited to 3 VLANs. So I can't do inside, outside, DMZ, and then start adding additional VLANs, right? So I'm going to be limited to 3 because I have what's referred to as the base license, right? That's the base license. And there's an advanced license that you could get, and you could find that on a system probably already on eBay. These firewalls, I got these for, I think it was $60 a piece. So for the ASA 5505, if it's something you want to get to experiment with, it was around $60. And again, you should be able to find a later version with 512 meg. And you need the 512 to run the 9.x code. And that's really where you want to be. All right, so we did the show version there. Let's do the show version over here. And it kind of flew by us there. It didn't stop, but you can see kind of the same thing, right? And so we do see very similar output here, and this, because it's software emulated, is 512 meg, and we're running 842. And again, that's definitely a later version of code. Okay. The various aspects of the ASA device. So enter privilege exec mode. A password has not been set. Press enter when prompted for the password. Well, we already are in privilege exec mode. And now let's say show file system, right? And we can see, and these are synonymous terms, right? Disk 0 and flash are the same thing, right? They're synonymous. So when I say disk 0, I'm going to see the same thing I say. If I say dir disk 0 colon, I see that. If I say dir flash colon, I see the exact same thing, right? So those are synonymous with each other. And I already did the show file system command, and that just shows me how much space we're looking at, right? You can see the size right there. Okay, let's see where we're at. Part 2, configure ASA settings and interface security using the CLI. So it says many ASA CLI commands are similar to, if not the same, as those used with the iOS CLI. And the process moving between them is essentially the same. Now, this is true and it's not true. And let me show you what I mean as we get into the configuration here. So the first thing we're going to configure, let's get into global config with config terminal or configure terminal. We're going to set the host name. And I'm going to say hostname CCNAS-ASA. And I'm going to hit enter. And then I'm going to say do show run. Because with iOS, when we're in global config, we have to say do show run. And I'm going to hit enter. And we're going to be presented with an error. And this is typically what throws learners off immediately. In fact, if I go over to the real Cisco ASA, and let's go into global config, and you're going to get prompted with this. I'm just going to say, no, I don't want to report information to Cisco. And I'm going to say hostname CCNA, and what was the name again? CCNAS-ASA. And I'm going to say do show run. And you'll notice we get an error. Now, this is one of the significant differences between the ASA operating system and iOS, is all I need to say here is show run. I don't need to prepend or precede the command that I wish to run, which was a privilege exec command. If I'm in global config, I don't need to put do in front of it. I simply need to run the command. The ASA doesn't care that I'm in global config mode. So when I say show run, we see everything, right? So you don't have to say do. That is a significant difference. Now, the domain name. So domain name is ccnasecurity.com. And did I spell security right? ccnasecurity.com. And we go from 23 to 25, so I did get it spelled right. So again, we'll drop over here, and I'm just going to say domain name ccnasecurity.com. All right. The enable password. Now remember, by default, there is no enable password, so we're going to use an enable password, or the enable password command, to change the privilege exec mode password to Cisco ENPA 55, one of our favorites. Now, this is also a little bit different. You'll notice on the ASA, and I think this is true of 9.1 code on the 5505, is that there is no algorithm type option, right? So we can't do script and we can't do SHA-256. It's just going to be MD5. And so let's go ahead and say enable, and then we'll get, enable password. Now, and again, this is a little different. You'll notice we don't say enable. Let me come back here. There's no secret, right? On a router, we would say enable secret if that's what we were doing. But here we don't. On the ASA, you say enable password, and then you enter a password for the privilege level, so Cisco ENPA 55. And if I do a question mark, if it was an encrypted password, I would use encrypted, right? If what I put in for Cisco ENPA 55 was the hash, I would then say encrypted, but it's not. So I'd leave it in plain text. Now there's a level. It says enter this keyword to specify the privilege level. So if I don't put that in, and then I say do show run, what do we get? I'm sorry, show run. What do we get for the password? I think I went right by it, so let's scroll back up a little further. You can see that it now gives us this encrypted enable password, but I didn't put the level in there. So let's see what happens if I log out. If I say end, and let's do write mem, right? That's still going to save my configuration. I'm going to exit out. And then I'm going to say en to get back into privilege exec. And now if I hit enter, you'll notice it says invalid password because we made it Cisco ENPA 55. And it still puts me at privilege exec. And it's going to be much the same over here. If I say username, wait a second, did we set username? I'm sorry. No, just the enable password. So I'm going to say enable password, and it's the same thing. Even if I came back here, you'll see it's password. That's my only choice. Enable password, and then my word, Cisco ENPA 55. I have the same options, encrypted or level, but I'm just going to hit enter, do show run. I'm sorry. So definitely a router guy. Show run, include enable. And you can see that there is the enable password. And it's interesting. Is that pretty close? SYCML. I'm curious if that was close to what we saw earlier here when we said show run. No, okay, not the same. All right, so we've got our hash, right, the MD5 hash right there, and we're good to go. Now, we're going to set the clock, and which is interesting. When you're on a router and you go to set the clock, you do it from privilege exec mode. When you're here, right, if I was to say clock set and do a question mark or do set clock, right, we don't have anything. So we have to be in global config. So again, another little minor difference between the ASA and iOS. So here's where I'm going to say clock set, and the syntax is the same, and I'm going to use UTC time, so that'll be plus 5 hours. So if it's 10:47, it would be 11, 12, 13, 14, so 47:00, 00, and it's 19 February 2018. Right? So if I say show clock, there we go. And again, I'm using UTC time, which right now, before we leap ahead, or before we jump ahead an hour, is it? Yeah, we jump ahead an hour, I think, or yeah, spring forward. So before we spring forward an hour, we're plus 5. And so it's 15:47. All right, so that's the setting of the clock, and it says, it's nice, it says this step is not scored, right? And that's okay. And the command over here, the same thing. We would say clock set 15:48:00, and it's going to be 19 February 2018, and I say show clock, and now my time is set. All right, so now is where we're going to start to see some of the significant differences between packet tracer in a simulator and a real ASA 5505. And again, remember, all 8 of the switch ports that we have right now are currently in, I didn't want that, show interface brief, and what is it, show interface IP brief. All 8 of these interfaces, and I'm actually going to scoot this up a little further, all 8 of these interfaces here are all in VLAN 1 by default. They're all in VLAN 1 by default. So to move them into another VLAN, we have to configure that. In fact, if I say show run, you can see, take a look at what's already happened here. So it says interface Ethernet 00 switch port access VLAN 2. What does a real ASA say that hasn't been configured? So take a look at the real ASA, because these things that we're seeing in Packet Tracer, remember, some of them were pre-canned, pre-configured, and scored for us. So what we see from a real 5505 is that, yes, they're all in VLAN 1, and the reason that we know this is when that's the default setting on a switch, does it say it's in VLAN 1 under the interface running config? No. But when you change it to a different VLAN other than 1, just like all of these right here, you'll see these aren't shut down either, but they're all in VLAN 1. So how do we see that? We can say show, and does it support it? Is it show switch? I think it's show switch. Let's do show, yeah, show switch VLAN. That's what we want. So this is a killer command on the 5505 because it shows me right now what VLANs are configured, what interfaces are in those VLANs. And so this is concrete evidence and proof that by default, an unconfigured, new out of the box or recently wiped ASA 5505, all 8 of the interfaces are going to be in VLAN 1. And VLAN 1 is down because, again, we don't have anything plugged in here, so it's going to show that it's down. And that is a great command, show switch VLAN, right? And unfortunately, show, it doesn't look like it's, oh wait, there it is, show switch. Why didn't that come up then? Okay, it is here. It didn't want to give me the context-sensitive help. All right, good. So here we go. And you can see right here, we've got VLAN 1. It's been named inside, and we've got 4 interfaces that are in that VLAN. And so I could plug PCs in to these 4 ports, right? Or I could plug a switch and then plug 100 PCs in, right? All my devices on my inside, trusted, protected LAN segment. And then VLAN 2 is the outside, and that's just Ethernet 0, 0. Now, I'm also going to talk about the little script that you can walk through when we configure the factory defaults, right? I'll show you how to do the factory defaults on the real ASA as well to kind of, prompt you and get you some configuration experience. So here we go. We're on the ASA. Now we're going to configure the VLANs. It says you'll only configure VLAN 1 and 2 inside and outside respectively at this time. So VLAN 3 is going to be done later. All right, so let's get into interface VLAN 1. And we're going to name it. I'm going to say name if inside. Now you'll notice when I hit enter here, it's just going to act as if I'm entering any other command in, right? So I say name if inside. It's like, okay, cool. IP address 192.168.1.1. So this is going to be my 1.1. This is going to be my default gateway for my hosts. And it's a /24, so dotted decimal subnet notation of 255.255.255.0. And I hit enter again. Now it's asking me to put the security level in here. And the reason that we have to do this, remember, when I did the check results, it showed us that some of these things had already been done. Specifically, these settings here short of the IP address. What does this look like on a real ASA? So interface VLAN 1, right? And if I said show run interface VLAN 1, here's what we would see right now is we have no name, no security level, no IP address, right? So not looking good right now. So I'm in interface VLAN 1. I'm going to say no shut right out of the gate. I'm going to name it inside. Now I want you to see what happens here. Take a look at what the ASA operating system does for you. It says info, security level, so it's giving me this message here. Security level for inside set to 100 by default. And it does this by default because we're using the keyword inside, right? If I was to go into interface, and oops, sorry, let me pull this back here. If I was to go into interface VLAN 99, let's say, right? And I said name, and VLAN 99, I just created that, right? Arbitrarily chose 99. I'm picking 99 for whatever. And I name it, let's see, partner zone 9, and I hit enter. Take a look at what it does. So it simply puts it at the lowest possible setting. So the keyword inside triggers the operating system to say, hey, you're telling me this is your inside trusted interface. I am setting you to the highest security level that there is. Whereas everything else is not. Everything else is going to get set to 0. And then I would have to go in and I would have to say, you know, security level, whatever, 50, depending upon where I want this in the use case, right? And we'll see this with the DMZ, that we set the DMZ somewhere between the inside, so lower than the inside, but higher than the outside. And this gets into that conversation of, by default, the ASA allows the flow of traffic from higher level security interfaces to lower level security interfaces, but not the other way around. So if I'm coming from inside, security level 100, I can go to the outside by default, which is going to be security level 0 by default, but it doesn't work the other way around. So as soon as these interfaces are configured, traffic from a lower level, like the DMZ that I think we set to 70 on the activity, that is not going to be allowed to go into the inside zone. And in most cases, you wouldn't want it to be allowed to go into the inside zone because it's out in your DMZ. And that's typically where you keep your web servers, right? Which are constantly getting exploited. So here we are, security level 100, and that is it. So we had to type in the security level, although technically on a real ASA, it's going to do that for you by default. Now let's go ahead and do, excuse me, the outside interface. So interface VLAN 2. Name if outside, it would set that to 0 for us by default on a real ASA. IP address is going to be 209, and this is if you have a static, 209.165.200.226. If you're doing DHCP, you use a different setting, 255.255.248, so it's a /29. And I'm going to have to type in security level 0, right? Again, the activity is scoring us on these things in some cases. In some cases, they've already been scored. So now we're set here. So if I say show switch, or sorry, is it show? Yeah, show switch VLAN. There we go, show switch VLAN. And so now we can see that Ethernet 00 has already been put in the outside, and Ethernet 1, 2, 3, and 4. And it looks like it may come down here to 5, 6, and 7. Those are all in the inside. And so let's finish up our config on the real ASA over here. So interface VLAN 1, right? So name if is going to be inside, and we put this on there already. Security level, I don't have to put this on here, right? Because it did that auto-magically. IP address 192.168.1.1/24. Interface VLAN 2, and we'll give it a second here. Interface VLAN 2, name if is going to be outside, and watch what happens. Now, we get this nice error here. This license does not allow configuring more than 2 interfaces with name if and without a no forward command. Because remember, when it's talking about interfaces, it's talking about VLAN interfaces. Remember, I did VLAN 99. So let me do this. No interface VLAN 99. So interface VLAN 2, name if, whoops, outside. And by default, it sets it to 0. And so I don't have to say security level 0. We'll say no shut. And do show run int VLAN 1. I'm sorry, show run int VLAN 1. That's always a tough thing. Show run int VLAN 2 is not having to say do is sometimes a tough thing. 209.165.200, especially when you do that all the time. 226, and then 248 is our subnet mask and dotted decimal notation. And there we go, right? So back to the activity. So we've got the VLANs configured. So it says here, use the following verification commands. We're going to use the show interface IP brief. And this is different. Remember, with iOS, it's show IP interface brief. That does not work on the ASA. You have to do show interface IP brief. Why that is, I don't know. I've never understood why they changed it on the ASA, if for no other reason to confuse routing and switching folks. Okay, so there are the interfaces. You can see interface 00, 01, and 02. These are up. And we get down here, we see the VLANs, right, are switched virtual interfaces. And here's what you would have to do that we're not doing right now. Excuse me. And so the step that's missing here is when I say do show run. And in fact, sorry about that. When I say show run, that'll not be the last time I do that. you'll see for Ethernet 00, which is the outside interface, right? It's this interface right here on the firewall. You see we say switch port access VLAN 2. So it's similar to what we do when we create an SVI using a VLAN, and then we have the opportunity to go to individual switch ports and place them into their respective VLAN for access. So on a real ASA, and let me see, do show run. I don't think it matters here. Show run. So yeah, so we'll stick with the same thing that they're doing here. So interface Ethernet 00, right? You'll notice there is no IP address command here, right? So if I tried to say 209.165.200.226, error. The command can only be configured on a VLAN interface. And so now we've got to do what we would normally do here on a 5505. I'm going to say no shut to bring the interface up. And then we would say switch port access VLAN 2. So now when I say show run, you can see that we've got interface Ethernet 00. It's in VLAN 2. All of these other interfaces that we saw when we did the show switch VLAN show that they are in VLAN 1. So now when I say show switch VLAN 00 is in VLAN 2. It's in the outside. So the connection that I would make from the service provider, and I'm sorry, I'm not sure why this went to the blue screen. Let's give it a second here. So the interface that you would take from your provider, Comcast, whomever the case may be, you're going to be plugging that into Ethernet 00 right there. Excuse me. Okay, so we've got that taken care of. We took a look at the interfaces, and let's see what we've got. Show IP address is another one, right? Shows me the VLANs, the SVIs, the switch virtual interfaces, and the IPs associated with them. And then there's that show switch VLAN. It is supported, right, on Packet Tracer. So there we go. Now we're going to test connectivity to the ASA. So you should be able to ping from PCB because this is on the inside. The trusted network and the trusted interface, the inside interface. And what did we say the IP was? Well, it was that default gateway 192.168.1.1. So for PCB, right, and let's check it. This is already configured. You can see here, there's my default gateway. And it's the same interface we used on the ASA, or the same IP address we used on the ASA. Now, step 5, from PCB, ping the VLAN 2 outside interface. You should not be able to ping this interface, and this is going to lead us into a brief conversation on the Modular Policy Framework, or MPF. So in the 209.165, 200.226, as you can see, this is not going to work, right? Because we've got an ASA firewall, okay, with default settings. And so what's happening is the user that's here, right? So here's Joe, administrator on the inside network, sending a ping packet, and it hits that interface right there on the firewall. Now, this is a higher level interface. And by default, you should be allowed to go from a higher level interface to a lower level, security level interface, right? Because it's 100 here and it's 0 here. However, the modular policy framework is inside the ASA firewall, and it's inspecting the traffic that comes into the interfaces on the firewall. There's a default global policy in play here. And what is not set up in that default global policy that we will be changing is ICMP is not inspected. And so remember, how did the router, when we did the CBAC, or the zone-based policy firewall, if we weren't inspecting the traffic and I sent a ping packet, right, out to the internet, and let's say the PC is here. So if I allowed the traffic out, right, the default policy was to allow the traffic outbound, but when it came back in, if I didn't have a policy if I didn't have a policy when it came into the interface that was inspecting ICMP in particular, the return traffic is not allowed because there was no session set up here. And it's much the same with the ASA, except the ASA doesn't use the zone-based policy firewall. It doesn't use context-based access controls, right? So those are router firewall features. Here we're saying, yeah, we're a little bit larger of a company, and we're going to go with another physical device that is specific to firewall functionality, that we're not going to incorporate that into our border router. Okay, and so it does the same thing, is that the ICMP packet comes into the firewall, but we're not going to get anything back because we are not inspecting ICMP at this time. And so let me do this. In fact, I'm curious to see if this works. Let me do, and so that's the 226, is that right? Is that the R1? No, that's the outside interface on the firewall. What is the interface? Hopefully we can see this here. Let me look at the config. Whoops, let me look at the configuration. So on this firewall, Cisco Con PA55, EN Cisco EN PA55, and let's do a quick show run here. And we've got a username, SSH admin. All right, and so we should have login local. We do transport input SSH. Okay, so SSH admin, and what is, so it's 225. So right now, if I was to say SSH -L SSH admin to the 209.165.200.225, would we expect that this is going to work? And the answer is no. We get the connection timed out, remote host not responding, right? So, and it might have something to do with the fact that the default, I think there's a note here that the default is not set up, because by default, it's looking at certain things, right? TCP being one of those, the modular policy framework. So I'm not going to get too far off track here. All right, so we should not be able to ping the address. We were not able to ping the address. So now we're going to configure routing. We're going to configure NAT, and we're going to configure the inspection policy, right? So how do you do a route? Well, very similar, very straightforward. Let's get back to global config mode. You simply say route outside. So think of it like this. My route to the outside interface, right, for all traffic that I don't have a longer, more specific match to is going to be to go to the 209.165.200.225. And in fact, this is why my SSH did not work. And I thought that that might have already been set up for me. So let's bring this back here. And I'm on B, I'm on C. I want to be on B. So let's bring this back and let's rerun this command. And if this still doesn't work, it could be, again, that we don't have the NAT set up or that it's not pre-configured to do the NAT for us. All right, so there we go. So we've got the route entered. Issue the show route command to verify the static default route in the ASA routing table. So to do that, we simply say show route, right? And there is my static default route. So it looks very similar to a router routing table. All right, now verify the ASA can ping the 10.1.1.1. If the ping is unsuccessful, troubleshoot is necessary. So the 10.1.1.1 is router 1's serial interface over here. So can I get to that? And we may have to lose a packet first, and we do, and then it works without a problem. So this is traffic being generated by the firewall, because if you're looking at that and you're saying, well, wait a second, you couldn't ping from C or from B just a minute ago. So why is it that all of a sudden the ping works? Well, this is not transit traffic. And this is, again, this is where it gets really confusing when you're first being exposed to ASA technology and firewall technology in general. This is management plane traffic, right? This is being generated, or control plane traffic being generated by the ASA. It is not transit traffic that came in to the ASA through an interface and is then egressing out another interface. And that's the definition of transit traffic. So when I'm saying transit traffic, to meet that criteria, it would have to enter one interface and then exit another. If it doesn't enter an interface on the ASA and then exit another interface on the ASA, it is not transit traffic. And so when I ping from the ASA, right, the traffic is originating on the ASA and going out. Therefore, it is not being inspected by default. Now, you can certainly do that, but by default, that is not happening. All right, so it works. So now we're on step 2. Let me scroll down just a skosh here. We're going to configure, and oops, sorry, we went a little too far there. Hold on. We're going to configure address translation using PAT, or port address translation. So in other words, we're going to allow all of these devices, right, to simply use the single outside static IP that we have on that outside interface in order to become publicly routable once they hit the outside interface. So how do we do that? Well, it's all about objects, right? And so you can see there, it actually, pretty soft landing here. It's going to go ahead and give us the syntax that we need. And so in order to do that, let's go ahead and set this up. And we're going to say, and everything is an object, right? Everything is, and I know that sounds a little bit like Python programming, right? Everything's an object. But with the ASA, it's kind of the same philosophy, that everything is an object. Whether it's a network or a host, it is an object. So we're going to go ahead and say object network, and this is going to be the inside net. So we have to define an object that describes the inside network. Now, beginning with ASA version 8.3 is when all of this was used, and specifically to configure NAT, which is why you don't want to be using like an 8.2 version. The syntax, it was extremely confusing and much different than this. So object network inside net. So I'm basically creating an object for this subnet here, 192.168.1.0. And there we go. And now I'm going to go ahead and do the NAT statement for that network. And so I'm basically going to say, so to do NAT from the inside to the outside, right? So when doing NAT from the inside interface to the outside interface, do it dynamically and use the interface IP. That is your port address translation statement right there. And we've just set up NAT, dynamic NAT, for the inside to the outside interface, right? And so we're going to hit enter, and that is it for that. So if I hit end, there's a command, it's show run object. I'm hoping it's supported here, and it is, right? So you see the show run object, and that's our object. So if we had other objects, which we will here shortly, I believe, you would see those here. So the SSH didn't work before, right? But now, at this point, we should be able to SSH. The NAT has been set up. The object has been set up for the inside interface, right? So we should be able to go and SSH from, and take a look at that, right? So again, I wasn't sure what was pre-configured, what wasn't pre-configured. So we're here, it's working. So what did we have to get done? We needed the network object for the inside network and the NAT statement. And you can see that TCP is being inspected by default. Now, let's see, will the ping work? And let me go ahead and try to get back here. Will the ping command work? And it should not, because we're not inspecting it. 209, and actually, let me just pull this back up here. Because the echo replies should not be coming back through. And it looks like that is what we are going to see. So I'm going to Control C out of there. So we're not inspecting ICMP by default. However, SSH, which is TCP port 22, is being inspected. And so that's why it's working. All right, so the ASA splits the configuration into the object portion that defines the network. I'm just making sure we cover everything here. Okay, so from PCB attempt to ping the R1 gig 00 interface, the pings should fail. All right, good. So I was a little ahead of ourselves there. And the reason that they fail is because even though the NAT and everything is set up, the modular policy framework by default is not inspecting ICMP. And they want us to run another really good command, show NAT. And so that shows me how many hits have been translated successfully and then how many were unsuccessful, right? And it actually gives you a little note. The outgoing pings were translated, so that's good, but the returning echo replies were blocked by the modular policy framework. Now, it says you will configure the default inspection policy to allow ICMP in step 3, which is what we're getting ready to do right here. Now, there's one other command that I wanted to show. In addition to show NAT, what about show XLate? Now, this is a great command too, and it shows you the NAT translations that have been done. So I can see right here the inside, right? Who's the host? So we've done, and this output's kind of truncated here. So port address translation from the inside host, that's PCB 192.168.1.3, and the random high port that it chose was 1027, going to the outside on that random port number, and you can see the flags are idle. So let's run the ping command again, and let's pull this up, and we'll say ping, and we'll get the firewall up here and see if we see anything additional. All right, look, oops, it looks like it's not going to give us anything additional. Still using that same random high. Now, on a real Cisco firewall, and this is actually the firewall I have in front of my actual, quote unquote, inside network. Here's what a translate table. Here's what a translate table looks like with lots of activity, right? So you can see UDP port address translation from inside 192.168.16. This is an ant miner, one of those Bitcoin miners, and he's going outside using the 71.179.54.69, and there's the port number that he's going to. And you can see that we get entries in here. So it shows me every port address translation being done. Do we have anything? I don't think oh, there we go, NTP, right? So here's a good one right here. So UDP, right? So the network time protocol is port 123, and you can see that it's being NAT translated so that I can get to the time server that's out there on the internet. And this is not the time server, right? This is my outside IP address. And that is 123 is the destination port number. So it's the source port number and then the destination port number. And this is showing me all of the port address translation, or the NAT XLates, the translates that are being done on the firewall. All right, so let's transition back to this activity here. And now we are here, the modular policy framework. And this is really the brains. And to draw a quick analogy, think of this as like the context-based access control engine, right? Where we were saying inspect TCP, right? And then the zone-based policy firewall was just kind of a really cool wrapper, but behind the curtain, it was still using the context-based access control engine. And so think of the modular policy framework as that context-based access control engine. It's the MPF, or the modular policy framework, that is driving what is getting inspected. And if I was to say, oh, sorry, I was going to do a show run, and I think I just pushed us way ahead in the activity. So there we go. I wanted to say show run to see what we see here. Yeah, okay, so here is the problem, right? So I'm actually surprised that the SSH works. So on Packet Tracer, there is no default modular policy framework, and that is not what you will see on a real 5505. There will be a default modular policy framework, and it is going to look like this, and you'll see it looks very similar to the zone-based policy firewall. At least the syntax is going to, the things that we have to change. And we have class maps, we've got policy maps, right? And we've got, so here we go, policy map, global underscore policy, class inspection underscore default. And so here is a list of, of all the things that I'm inspecting by default, right? So here's all the things I'm inspecting by default. And then you'll see here, service policy, global, which means apply this to all interfaces. The service policy, global underscore policy, which there is the service policy. It's defined by the policy map. So from right here, if I was to say, policy map global underscore policy, and then say class inspection, it's not going to finish for me, inspection default, and then I said inspect, and I do a question, we'll say, yeah, that should be right. Hold on one second. Inspect ICMP, or maybe I'm wrong in my syntax here. What am I missing? No, it shouldn't be match. Class inspection default. So I typed in something wrong here. Hold on one second. Let me take a look. So this is how you would actually add ICMP, class inspection underscore default. Yeah, because it's not match. We don't say match. Let me go up one level. And did I do it? All right, so yeah, I should be able to say policy map global policy. Let me copy and paste to make sure I don't have something wrong here. And then the class should be class inspection default. Copy and paste that. Yeah, and I must have typed something in wrong. I just didn't realize what I had typed in wrong. Okay, so you get into the, let me take a step back. You get into the policy map, and then from the policy map, you get into the class map. And here's where we would say inspect, and I'll do a question mark, and take a look. There's quite a few things that we can add in here. One of them is ICMP, right? So now I'm going to say end. And now when I say show run, and we come down to the default modular policy, the default modular policy framework, we can see that right here I've piggybacked or added in to the default modular policy framework inspection policy, ICMP. So now if we were to run pings and go from a higher level security zone to a lower level security zone, it's going to work. And this is why it's not working, even though it's kind of a pre-canned scenario here on the ASA. So let's go ahead, and now we're going to put in the code that they're looking for to get Packet Tracer to work with our ping commands here. So here, they're actually going to have us create class map inspection underscore default, and let me make sure I get that spelled right. And then we're going to match default inspection policy. So we're literally creating, traffic. We're literally creating sort of our own little modular policy framework. And again, very similar to the zone-based policy firewall command syntax and very similar to QoS. So now I'm going to exit out. And so here we go. We're going to get into the policy map, right? Global underscore policy. And class is going to be called inspection underscore. So very similar to what we just did, default. And then I'm going to say inspect ICMP, and then exit, and now we have to create this entry, service-policy, which, because it doesn't exist here in Packet Tracer, global underscore policy, and global, which means apply this to every single interface, right? And now, from PCB, let's try to ping out to that 209.165, and like it would with a regular Cisco ASA firewall, when I say ping 209.165.200.225, it is now going to work because now the traffic is being inspected. The ICMP traffic is being inspected. All right, the ping should be successful because it's now being inspected as legitimate traffic. All right. So here we go. Now we're going to do some housekeeping, right? We're going to set ourselves up to be able to use DHCP and some AAA, right? Authentication, accounting, and SSH. Okay, sorry, I'm just reading this real quick. Okay, so let's get into DHCPD, and the address. So we're going to set up a DHCP-D is the daemon, right? We're going to run the DHCP. So this is our DHCP server, not a router this time. 192.168, and I actually have my network at my house is set up the exact same way as my firewall is my DHCP server. 192.168.1.36. So this is going to be the range of addresses that I use for DHCP, right? That's going to be the range of addresses that I use for DHCP. So now let's go ahead and hit enter. Whoops, I'm sorry, and I need to put in there what interface? The inside interface. All right, so now we're going to put the address of the DHCPD, so the clients are going to need to know about the DNS server, and that's going to be 209.165.201.2. I'm not sure who that is up there, but it's one of those boxes up there maybe. And actually, let's make sure we get this right, for my inside clients. Okay, and we're going to enable, and this was already, these DHCP settings were some of the settings we may not be seeing points because these were kind of pre-canned. So now let's change PCB and let's see, do we get the DHCP address? Do we get the DNS server? Do I get the default gateway? And we didn't put that in. You'll notice I didn't put a default gateway in up there. Why do you think that is? Yeah, because it's the firewall, right? It's the firewall, and it's coming off of this interface, and so by default, that is going to be the default gateway address. So we get the first DHCP available address, .5, the net mask is right, the subnet mask is right, the default gateway is correct, and it even got the DNS server. Now, typically what you'll see when you set this up is you may enable, what is it, option 3. I think it's option 3. You may end up, and this is from, there's an activity that you would actually do in class if you were taking this in an in-class setting, and I think it's option 3, and I want to say that it has something to do, and I'm not even going to guess, I can't remember, but I think it's option 3. All right, so the client works, right? Let's test one other thing here before we scoot off of that. Let's see, can I still ping? Absolutely. Let's take a look at our XLate table. Show XLate, right? And here it is, right? Take a look. And you can see the 192.168.1.5, that is the new DHCP address. And we've got, and this was the legacy entry that is still in there, that's not going to time out for about 30 minutes, it looks like, or 30 seconds is not going to time out. So there we go. We've got that set up. That is working swimmingly. And now we're going to configure AAA, right? So we're going to configure a user here so that we can SSH into the ASA. Admin, the password is going to be admin PA55. Now I'm going to say AAA authentication, and the syntax here is much different. Authentication, SSH console, right? Local. So I'm using the local database, and console, this is important, that does not mean the console port. These two kind of go together, and it's sort of a legacy thing. It's console local, right? I'm using the local database, and that's really, the console is referring to the fact that this is a local database that we're using, right? So it has nothing to do with the console port in this syntax. In fact, and let's see if it's on here, authentication, what can we do? SSH. Yeah, so specify this keyword to identify a server group for administrative authentication, and that's where we say local, right? The local database. But when you want to get access to the console, let's pull up that Cisco 5505 ASA here. If I go into global config and I say AAA authentication, and I'm trying to remember, it's serial, right? So instead of saying SSH, you would say serial, because serial is representing the console port. And let me make sure that's correct. I'm almost 100% certain. Yeah, it's the serial. That's what you put in if you want to use AAA on the console port. When you say console, it's just referring to local is the predefined tag for the local database, or I would put in the radius or TACACS group name, right? But console in this context with serial, right? Serial means the console port. This console word that you're going to see with SSH and with Telnet and with serial here isn't referring to the console port itself, right? It's referring to the AAA group. So keep that in mind. And we have everything in here, I think. Is that right? Did I get that command in there? Yeah, so that's in there. Okay. Now we're going to configure remote access. And so sometimes you'll hear these referred to as sort of management ACLs, so to speak. But what we're really doing is we're just scoping on the given interface on the ASA, from where is it going to allow connections, or from whom is it going to allow connections on that inside interface, and from whom is it going to allow SSH connections from on the outside interface. So I thought this was interesting, is that it looks like they want us to run the crypto key generate RSA command, modulus 1024, but it says up here that it looks like the key, it says you already have a key pair defined, so say no, and they actually tell you to go ahead. It's almost as if they knew that that was going to be the case, and maybe it's because it might not be configured. So it is there, so you just simply say no, because we don't want to configure it. So now we're going to configure sort of the quote-unquote management ACLs, so to speak. So SSH, so from the 192.168.1.0 network, and this is going to be a dotted decimal notation subnet mask on the inside interface. So I'm allowing SSH from any host on the 192.168.1.0. And that's going to include PCB. And this is on the inside interface only from that subnet. Now, on the 172.16.3, who is this, I wonder? 3.3, is that the DMZ? It's not the DMZ. I guess that's probably PCC on the outside. Okay, let's check that out. So 255, 255, 255.255. So this is a host, right? A host ACL here, so to speak, where we do the /32, where all of the net mask is all 255s, because it's only this single IP address is going to be allowed to connect via SSH to the outside interface. And then let's set the SSH timeout here to 10 minutes. SSH timeout, make sure I say that right. Yeah, to 10 minutes. Okay. So now let's test SSH. So can I go from PCC to the ASA? So here's PCC. Can I get to SSH -L? And let me pull this down here so we can see the information. And they have just admin. Is that what we used when we set up the username? I can't remember. Yeah, it is admin. Okay. So SSH -L admin, and we're going to try to get to the 209.165.200.225, 226. And there we go. And so by allowing with this little management access, again, think of it like a management ACL, right? But it's based on an interface level. We're allowing SSH into the outside, but only from this host. And so it was Cisco ENPA55, I think, or what was it? What was the password? I can't remember the password. Admin PA55, sorry. Admin PA55. And there you go. We're on the firewall right now from the outside network. And maybe it's a remote office, who knows? Okay, and so that worked, and so we're good there. Let's scoot. Okay, we're all the way at the bottom of the activity. So establish an SSH session from PCB to the ASA, and this should work as well. So SSH -L admin 192.168.1.1, because we said anybody from this subnet is allowed to connect through admin PA55, and there you go. So we've just set up remote management of the ASA firewall. All right, configure a DMZ static NAT and ACLs. Now, router 1 gig 00, those are the interfaces. We're going to use 227, right? Because we've got some statics we can use. So we're going to use a static for the DMZ, and we're going to provide access back here to this DMC packet tracer server. Now, here's where we're going to see this forward message. So let me get into interface, let me get into interface VLAN 3, and I'm going to say IP address 192. In fact, we're going to see that message 168.2.1. Boy, oh boy, 192.168.2.1 and 255.255.255.0. And we're going to see, and this is where we would see that message, right? And you'll notice that they have us type this command in, but they don't tell us why we're typing it in, right? And we don't see what. We don't see what we would have saw over here, interface VLAN 3 and IP, and actually let's do show run. Let me make sure interface VLAN 3, because we've done some stuff here. No do. Sorry. All right, there we go. All right, so we're going to say name if DMZ, and here's where we get the error. This license that we have, the base license, doesn't allow more than 2 interfaces with name if and without the no forward command. So what we have to say here, right, is that I'm going to accept the fact, so I'm not going to be allowed to forward traffic from the DMZ to the inside, right? It's not going to work. I'm not going to be able to initiate those connections, which in this case, if you think about it, right, that's what we want. You're not going to want connections being initiated from the DMZ into the inside zone. That's why we put things out in the DMZ like web servers, is that if they get compromised, we're protected, right? Now, the web server may be destroyed, but everything on my inside network is protected, and that's the important thing. Okay, so what did I leave off on here? So name if DMZ, and now we're going to change the security level, because by default, right, and you see here we get it with the DMZ, we see the default is 0, but we're going to set it to 70, which means that by default, traffic is allowed to flow from the DMZ to the outside. And traffic is allowed to flow from the inside to the outside, because the DMZ and the inside, 70 and 100 respectively, are higher security levels than the outside. But the reverse is not true. Traffic cannot initiate from the outside and come into the inside, and it cannot initiate from the outside and come into the DMZ. Right? It can't do that, and you'll see that's why we're going to set an ACL up to allow that to happen. So security level 70, and I'm going to do what here? Interface Ethernet 02, and we're going to say switch port access VLAN 3. So now Ethernet 02, which is that interface right there, the little diagonal one that comes off the side, that's Ethernet 02, that's my DMZ interface. All right, so let's go ahead. I'm going to save my config just to make sure here. We're going to say show interface IP brief, right? And there's VLAN 1, 2, and 3, my inside, outside, and DMZ respectively. Say show IP address, right? That's what we look like. Again, it's truncated a little bit. I apologize there. It's a little tough to look at. And then show switch VLAN. And there are the ports with their respective VLAN assignments and the name of the zone in which that port is participating. All right, so now, again, remember, everything is an object. So if I'm doing NAT, it's going to get done under the object definition. So what do we need to do? We've already got the VLAN configured. What do I need to do now? Yeah, if I'm going to be doing NAT, and I'm going to be NATing from the DMZ to the outside, just like I did from the inside to the outside, we're going to have to create we have to get a global config first, and then we're going to have to say object, and it's going to be another network object because it's a server, right? Before it was a network, right? We did inside net, I think was the name of it. Here we're going to say object network, it's a server. And we're going to put the host IP, the server IP. Now I'm putting the inside private IP address, and I think it comments on this at the end or somewhere. If not, I will. That when the return traffic comes back and it's being inspected or it's being evaluated against the access control list, and here's this order of operations comes into play again. Remember, we had that nice little diagram that showed the order of operations, and this is going to do much the same thing. So I'm going to say NAT So when I'm NATing from the DMZ to the outside, I am going to be doing that in a static fashion using 209.165.200.227 as my static outside IP address, my publicly routable. So we have the inside local, which is your 192.168.2.3, and then we have the inside global, which is how is the inside address seen globally on the outside. So inside local, how is it seen locally? It's seen with its RFC 1918. It's 192.168.2.3. How is it seen? How is the inside seen globally? When we NAT it, it's 209.165.200.127. And I believe that that is it. I thought it was show object. I'm drawing a blank here. I thought I could say show object. I can't remember the command. I'm just drawing a blank. I'm sorry. I swear you could say, I can't remember what the command was all of a sudden. All right, it'll come to me. Okay, so here we go. So we've got the outside DMZ done. We're at 95%. The only thing left to do, right? Because remember, is traffic from the outside allowed to come in to be initiated out here, somewhere out here on this network, right? And we're saying that, you know, this is the outside, and actually that's a terrible rendition of the outside. So the outside is going to be, let me clean this here. The outside is going to be, and I'll make it much nicer to look at here. So everything over here, right, that is the outside, because that is my outside interface. Everything in here is either the inside or the DMZ, and we want to protect these things, right? We want to protect these things. Some more than others, right? But this is how we're going to set it up. Okay, so when we go to initiate the traffic from the outside to the DMZ, right? We're going to come in this outside interface. Are you allowed by default to go from a lower level security level to a higher level security level? No. If that is what you want to allow, we are going to have to do ACLs to say that traffic coming inbound on the outside interface, right? This access group that we're going to apply, we're going to evaluate it against that access control list. And this is how we allow traffic that's being initiated. Again, because we don't want it to be initiated to come into the inside zone. That would kind of be crazy. You want to allow it into your DMZ. Because again, we're saying that this is, you know, and yeah, it looks like we're going to pretend that it's a web server, right? And that makes sense because this would be where you would put www, your web server is out in the DMZ. But here's how you, excuse me, here's how you do static NAT. So let's clear the screen. Let's bring the ASA up here. And let's get into global config, excuse me. And I'm going to say access list. And you'll notice outside -DMZ permit ICMP. So we're going to permit ICMP traffic from anyone to the host, and this is to our web server, 192.168.2.3. So we're allowing ping traffic inbound to be initiated from the outside world, the internet, to come in that outside interface. But we also want to say, yeah, you know, legitimate people are going to be surfing the web outside DMZ permit TCP any, so from anywhere on the internet, only to the host 192.168.2.3 equal 80. And then we're going to go ahead and say access group. Now, you'll notice, this is interesting, very interesting, right? When I did an ACL on the router and I wanted to apply it to an interface on the router, what did I have to do? Yeah, remember, I had to go into the interface and put the access group, right? But here with the ASA, I simply say access group, the name of the ACL I've created, so outside to DMZ, I'm applying it in the inbound direction to interface outside. So inbound traffic, ingress traffic coming into, and remember, this would be inbound. That is the inbound direction. It's not traffic coming from the DMZ going that's not inbound. That is out. That would be going out that interface. This is coming into the interface. So let's clear that screen there and get back control. All right, so we say access group outside DMZ, inbound on the interface outside, and that should probably get us 3 points, and it does. Puts us at 100%, and external host access a server using its public. Oh, right. Okay, so important here. There is so there's a note. So unlike iOS ACLs, the ASA ACL permit statement must permit access to the internal address. And that's a key takeaway here. You'll notice I didn't put an ACL here with the 209.165 because the order of operations on the ASA is it's going to do the NAT translation first. Then it's going to evaluate the access control list entries. And so that's why we put it there. So at this time, the packet tracer was created. We can't test the DMZ web server. Well, let me see here. Can we ping it? Let's give it a try. Let's see if we can ping that ping 209.165 200.227. And maybe it'll work. Maybe it won't. It says it won't, but let's give it a shot. Who knows? Yeah, so it looks like the ASA here might not be configured to make that. Oh, wait, whoa, there we go. All right, it is working. Fantastic. So we're able to go through the firewall, and this is a great use case. All right, I'm glad this is working. So show XLate. Let's see what it looks like. Do we see anything in the translation table? Oh, yeah, there it is. Good. Here it is right here. So take a look. So from the outside, right? The DMZ IP is 209.168.2.3 to the outside 209.165.200.227/32, right? There's the translation that's being done. So we see that it is successfully translating that with the static NAT entry, right? So very nice to see that in here. And you can see right here the flags, right? Static, S is static. Okay. And what else do we have? We still have this dynamic entry from the inside to the 226. And I think if I said earlier these are port numbers, that is not the case. I don't believe those are port. I think that's has something to do with the session IDs. Okay, so that is it. That is going to do it. So as a quick reminder, if you want to grab an ASA, or maybe you've already have an ASA 5505, this little series, and you can just follow the blue dots. It goes in order. I did put some significant work into this to make sure that it was as comprehensive as possible. So you can follow through these, and it'll take you cradle to grave. It does static IP. It does. It shows you how to do DHCP on your outside interface if you don't have a static IP. It shows you how to do just about everything you'd want to do with the 5505 firewall. All right, well, that is going to wrap up Packet Tracer Activity 9.3.1.1, where we did some basic configuration on the ASA 5505. All right, guys, this is your penultimate Packet Tracer activity. One more to go, your skills-based assessment, and that is a monster activity, so make sure you're prepared when you sit down. All right, thanks for watching, and I'll talk with you soon.